Hmm. So let us start with the concept of refraction. We know that light travels in a straight line, okay? But when there is no change in medium, it means, suppose this is, so there is this medium, okay? Say it is here. So light is traveling through this medium, then there will be no deviation in the path of this light. But what if the medium changes? So let's say we have air, okay? So we have air above and below we have another medium, let's say water, okay? So in air, the light will be traveling in a straight line known as a plane propagation, okay? Now the light enters from air to the water and we can see there is change in medium, okay? So whenever there is change in medium, the direction of propagation of light changes. So at this interface, it will bend a little, okay? So simply we can say that whenever a light enters from one transparent medium to another transparent medium, it bends. This phenomena is known as refraction. This phenomena is known as reflection of light. Okay. So as you can see, it bends on this interface. Okay. And when it enters into the water, then again it start propagating in a straight line because now the water here we have the same medium, that is water, okay? So it will not keep bending, so it will bend at the interface, okay? So when there is no change in medium, light will travel in a straight line, and whenever the medium changes, the light will bend at the interface. So this is known as refraction of light, and we can define as when a light travels from one transparent medium to another, its direction of propagation changes. This phenomena is known as refraction of light. Okay, so now we will look into the laws of refraction. Okay, laws of refraction. Now consider two medium divided by this interface. So we have medium one, and below this interface we have medium two. And as we saw in the reflection of light, perpendicular to the mirror was known as a normal line, the imaginary line drawn perpendicular to the mirror. Similarly, we will draw an imaginary line perpendicular to this boundary. This line is again normal. Okay. So now the ray of light hits the boundary of both the medium, boundary separating both the medium. Okay. So this is your incident ray. This is the incident ray. Now, when there is the change in medium, its direction will change. Okay. So let's say it bends and moves in this direction. Okay. So the light got refracted. Hence, this ray is known as refracted ray. Okay. The angle which incident ray makes with normal is this angle known as angle of incidence, and the angle which refracted ray makes with the normal is known as reflected ray. So now coming to the laws of reflection. First law says that the incident ray, the reflected ray, and the normal all lies on the same plane. So as you can see, it can be drawn in the plane of the uh, paper on which I am writing. Okay. So the incident ray, the reflected ray, so not the reflected, it's the refracted ray. The refracted ray and the normal at the point of incidence lies on the same plane. Okay. So what is the point of incidence? The point where the incident ray hits the boundary. Okay. So this is the point of incidence. So all the three lies in the same plane. Now, the second law. The second law says that so we have angle of incidence I. So it is an angle. You can take sine of this angle. Okay. Sine of this angle. So you take sine of angle of incidence. Then we have this angle, which is angle of reflection. So take the sine of angle of reflection. You only want this sine. Okay. So we have trigonometric ratios, sine theta, cos theta, and theta and okay. So this sine, this one. Okay. We take sine of angle of incidence and then sine of angle of reflection and we divide both of them. Okay. And we get constant. So it is always a constant for a given pair of medium. We'll come to that. What do I mean by given pair of medium? But you have to remember this. That sine of angle of incidence, the ratio of sine of angle of incidence to sine of angle of refraction is constant. And it has a name which will be very important to us throughout the chapter. Okay. So what we can write? The ratio of sine of angle of incidence to sine of angle of refraction is a constant for a given pair of medium and wavelength. Okay. Now we'll come to that part. What does it mean by given pair of medium? Okay. But this ratio is a constant and known as refractive index of medium 2 respect to medium 1. Okay. So this constant has a name. Okay. And the name is refractive index. Okay. This constant is known as refractive index of medium 2 with respect to medium 1. Okay. Now we'll see what do we mean by it is a constant for a given pair of medium. We'll just have a quick look. Okay. So suppose there is this medium dividing air and water. Okay. And light goes from air water, obviously it will bend a little. So this is angle of incidence and this is angle of refraction. Okay. So for air and water, we took the sine of angle of incidence and sine of angle of refraction and we divided it. And let's say we got some value, let's say 1.33. We can get anything, let's say it's 1.33. Okay. Now we can change this angle of incidence and obviously the angle of refraction will also change. Okay. So I will change, R will also change. But again, we can take the sine of angle of incidence and sine of angle of refraction and divide both of them. Again, we land to this value 1.33. Okay. But what if we change one of the medium? Let's say for instead of air and water, we take air and glass. Okay. So now we will have some angle of incidence, we will have angle of refraction, and now we can take sine I by sine R. And not to be surprised, we won't get this value 1.33 again. Okay. So this is what I mean by mean by a given pair of medium. So this will be constant only for this pair, air and water. But for air and glass, it might be different. Okay. So let's say it might be 1.5. Okay. For air and glass. But again, for air and glass, for this pair, this constant, if we change I and R, take this sine of I and sine of R, we will land to this 1.5. So this is what we mean by a constant for a given pair of medium. And similarly for wavelength, so this value comes for a particular wavelength. Okay, so if we change the wavelength, basically the color of light. Okay, so if we change the color of light, the this value will also change.